Okay, so this is COMP3132, Applying Machine Learning Assignment 2. Now, the first part, we're going to import the libraries, just as we should do. And then here I had to actually mount the drive where the CSV file is located. Otherwise, I wouldn't be able to read it with a read underscore CSV method. So basically, what we did here is to define a variable for the CSV file, so then we could read it with a method. So this is why we had to mount the drive up there, and then we have to check the sum, to check the rows and the columns, and then we show the first row. Yeah. Okay, so part two. What we've done, part two, is actually map the classes, the class names, from strings to IDs. So we convert them. Right, so it's a conversion, and we check the conversion if the conversion was made correctly and if it is clean for training. And this is basically what we did here at part two. Alright, so now moving to part three. What we did was actually create a variable x with the first 4 columns, and then we create a variable y with the last column, which is actually the target label, the one we want. Now part 4, we prepare to train and test with datasets, splitting. So we're splitting them here into xtrain, xtest, ytrain, ytest, and then we get the first 5 rows of each. Okay, so now part 5, we actually, yeah, this is the only cell for part 5. So part 5, we convert them into one-hot arrays to categorize them. And yeah, that was it for part 5. Now part 6, we build a sequential model, and with two hidden layers and an output layer with using softmax. Then we use RMS prop as an optimizer to adjust the weights depending on the loss we have. Now part 7, this is actually where the training happens. We run 20 epochs over 10 batches, and this is the result. Now part 8, we evaluate the performance, and then we check the loss and accuracy, and then we print them. Part 9, we do pretty much as we did on part 6, except that we just use fewer neurons and layers, as we can see here. So, and therefore we run fewer epochs, as you can see here, but the same sequential model, just like we did before. We still use RMS prop as an optimizer to adjust the weights. We run over 10 batches again, but fewer epochs, and yeah, and that's the result of the training. And again, we evaluate the loss and accuracy and print them again. Now moving to part 10. Part 8, actually answering these questions. This one I actually already answered about the hidden layers and units. Now, do we always suffer from overfitting? It depends. Depends on the number of epochs, according to the number of according to how large the dataset is. So the number of batches of the dataset, so how large it is, to the number of epochs you run. Now, how can we detect overfitting? You can detect overfitting when the model starts memorizing the answers, just like I answered on assignment 1. Overfitting is when the model stops learning and it starts memorizing the answers instead of predicting correctly. It's actually trying to guess based on memorization. And how do we reduce overfitting? We can use dropout, and this is a very good idea to reduce overfitting. It's one of the best, actually. Dropout, or you can reduce the number of batches. Sorry, you can reduce the number of epochs, or you can provide more data. So a large data set to a small, to a smaller, not really big, but ideal size of a ideal number of epochs run. That's good. So, but you gotta watch out for the learning rate. But when you run too many epochs for a very small data set, that's when the overfitting starts happening, because then it's going to memorize every answer. And also, the number of epochs cannot be so small, and the data set be so huge, because then it's going to be not overfitting but underfitting. So here we use a different optimizer. We used Atom as an optimizer, and it's kind of a mixed Atom to kind of a mix. So in my opinion, I think it's better than RMS prop to adjust the weights. So it actually uses the current gradient with the previous ones, the old ones, and we where is it? Oh, here it is. And then we introduce a bit more. We run a bit more of epochs to see how it works with Atom, and yeah, that is it. So we got to be careful with overfitting and underfitting, and so we got to watch out for the learning rate. And this is why Atom is important, to watch out for the learning rate so the model can learn properly without wasting resources and time on GPU.